ADMAS 2012, Paper 2, Question 10. We'll start by drawing a force diagram, and there will be equal and opposite tensions in both strings. A has mass 5, so its weight will be 50, and B has mass m, so its weight will be 10m. We're told that m's less than 5, so the A will go down and B will go up with acceleration A, which we know is 2.5. So if we deal with A, resultant force in the direction of motion is 50 minus t, and that has to equal mass times acceleration, so that's 5 times 2.5, 12.5. If we look at B, then the resultant force is t minus 10m, and that will have to equal 2.5 m. Adding those two equations together, the t's cancel out, and we have that 50 minus 10m equals 12.5 plus 2.5m. So we bring everything together. 50 minus 12.5 is 37.5, and that has to equal 12.5m. So m must be 3 kilograms. That means that t minus 30 equals 7.5. So T must be 37.5 newtons. Now you'll see I've answered these questions in the opposite order, and that's the way that I've taught you to approach these questions. Form the equations and solve them simultaneously. Just go back then and write in the parts beside the answers. So we're asked for tension first, it's 37.5, and mass, which was 3 kilograms. We're then asked for the force in the pulley. If we look at the pulley here, we have a tension acting down, a tension acting down, so there must be a force F acting up. So F will equal T plus T, so that's 2T, so that's 2 times 37.5, and that gives us 75 newtons. They've been moving for 1.5 seconds at an acceleration of 2.5. When the strings become slack. They were released from rest, so we need to find the speed when the strings became slack. So V equals U plus AT, so that's 2.5 times 1.5, which is 3.75 meters per second. B will continue to rise up, so B, after A strikes the platform, B is moving initially at speed 3.75. It will stop moving when V is 0. It's now moving under gravity because the tension's slack, so the acceleration is minus 10, and we want to work out how far it has moved up. So V squared equals U squared plus 2AS, so 0 has to equal 3.75 squared minus 20S. 20S equals 14.0625, so S will be found by dividing that by 20, and that gives us an answer of 0.703 meters. We want to work out how much time that B is rising for, so I'm going to use V equals U plus AT. So 0 has to equal 3.75 minus 10t. 10t is 3.75, so t is 0.375. B's got to rise up and then come down, and then the string will become taut. So the total time before the string becomes taut is 0.375 times 2, and that gives us 0.75 seconds.